in study of the climate. And we are really fortunate to have him lead us in what we hope is going to be our first class of 1963 Zoom discussion group. I was asking Sandy and Izzy how many of the class of 62 discussion groups they've had, and they said maybe about 4. And this is since their reunion last year. So do let me know if you'd like to lead a future 1963 Zoom. The college gives wonderful support and handles the logistics, and we really appreciate Scott volunteering to provide us with up-to-date information on climate change, which is one of the very hot topics in this day and age. So Scott, it is all yours. Do your screen sharing and everything else. We're looking forward to learning.
Hello to everybody and welcome to the discussion. As DJ said, this is something we're trying for the first time. So whether I volunteered or I was volunteered, it's not exactly clear to me, but we're going to try to have a great discussion on climate. This is a follow-on to the discussion that we had in 2018 when we were last together. But a lot of things have happened, so I've updated the presentation. I'm going to try and close this so I can see. So to open up, I just wanted to say that as everybody knows, it's a tough topic to cover in 40 minutes. That's what I'm going to try to do. Sort of a little background is I wanted to give a little bit more than is available in the public press, and yet, you know, still keep a focus on what's very insightful. And, you know, there's a lot of science things, but I didn't want to get too enmeshed in the details. So those are the caveats that I started with. And so that's sort of my backroom discussion. A lot of things, there's a huge amount of information, so a lot of things was left on the cutting room floor. And I'll leave it to you in the Q&A to ask about things that that I may have omitted. So to start out, I wanted to talk about how this all came about. And as I think many of you know, Evan Deerdorf and I left Swarthmore in November of 1963 after graduation to go to the Antarctic with the National Science Foundation and working for Bartol Research Foundation and the Franklin Institute. I don't think Evan's online tonight, but he and I worked together through that summer and then into the fall. He replaced Doug Thompson, 1962, who was at Merrick Sound for the year before. And I went on to build the Cosmic Ray Station in the South Pole. And the reason we went down there is that before we had satellites, think back how long that's been, the only way to study the solar system was to be at the poles, which funnel the solar particles into the poles. So this is a picture of the hut that I built and put electronics into, and that was my home for the year I was at the South Pole. At the end of that year, I was very fortunate that I hooked up with a group from Ohio State University, and they were studying climate and heat balance, and that began my interest in climate and climate change. We used the snow vehicles that you see there in the picture, and we left the pole on December 4th, 1964, to explore what's called Queen Maud Land, which is the upper right quadrant of the continent, if you're looking at it with 0 toward Greenwich up. And there were 3 traverses that we went on, and we collected a lot of data when we were on that way. As I mentioned in our class discussion in 2018, one of the things that we do is collect atmospheric data, because as the snow falls in the Antarctic, it's porous, but as it compacts, it surrounds the air that's trapped in it and forms bubbles. So by drilling a core and dating the layers on the core, much the way you would date tree rings with some of the methods that we used, we can determine pretty accurately what the gas content of the atmosphere was over a long period of time. And what we found is that from about 1975, when things were flat all the way back to recorded time, up to 2022, there was about a 23% increase in CO2. And that corresponds directly with the industrialization of the Northern Hemisphere. So it's pretty clear with that correlation that there is a good correlation between CO2 and industrialization. To a 99% degree of certainty, science believes and that that correlation is valid. I know there's some questioning on that, and we can talk about that later if you like. So the methods that we look at to determine whether the climate is being influenced by greenhouse gases is complex. Clouds contribute a great deal of the impact on the albedo of the Earth and how much sunlight is reflected and how much is kept in. We all know that on a cool winter night, if there's no cloud cover, it gets pretty cold. If there is cloud cover, a lot of that heat is trapped. Carbon dioxide does the same, and methane is another gas that does that as well. So that's sort of the physical model. I don't want to go into it too deeply, but those are the things that you have to balance if you're looking at what is causing climate change. Another important thing that we look at is sea level rise, and sea level rise is been fairly constant over a long period of time. There are tide monitors across the globe that measure things. And the surprising thing, to me anyway, is how long a period of time we've had a constant level increase in the amount of, in the level of seawater. This is the record for Baltimore. We have a fuller picture because now we use satellite altimetry rather than tide measurements. The rate of increase is higher in the Chesapeake Bay area, New Orleans, and Miami, just as a consequence of some of the differences in global temperatures. The sea level rise so far is caused by thermal expansion of the sea. As the sea heats, it expands, and by melting of land-based glaciers. And we'll talk a little bit about that in a minute. When we went to the Antarctic, what we wanted to do was assess what the ice cap looked like. At the South Pole, you're about 2 miles high. And when you determine what the base level of the rock underneath is, you're standing on 2 miles of ice. So we needed to map both the top surface of the ice and the bottom surface. And to do that, as we were on Traverse, we'd drill a 60-foot borehole, put some dynamite down in, and set that off and record it with geophones that were stretched out on the ice. The vehicle to the left is what we call the drill cat. You can see the vertical drill beside the flag on the drill cat. The next sled were the drill stems that we used, and the last sled was the dynamite. We felt that we were safe at that point, but I'm not so sure. Fortunately, we never had a chance to test whether we were far enough away from our dynamite catch. One of the things that happened to us is we would travel every day and stop at night and drill the hole and set off the dynamite. One day we had some breakdowns and we arrived at the station late. We were all tired. We all went to bed, but one of the scientists decided, let's just keep on schedule, and we're going to run the drill. He was the only one there. Well, as you might imagine, what happened is it didn't turn out so well, and he lost the drill stem down in a hole. So rather than catching up on science, we got to spend the next 3 days digging by hand a 40-foot pit to retrieve the drill stems, because if we didn't have the drill stems, we wouldn't have been able to conduct the science. And what we found was that the ice cap was fairly stable, and that we couldn't determine whether it was expanding or contracting. Since then, the same thing has really happened. The ice cap has been fairly stable, despite what you hear about glaciers melting and the like. The ice cap itself in the Antarctic has been stable, which is fortunate, because estimates have been made that if the ice cap melted, we'd have a sea level rise of about 190 feet, which would inundate New York, San Francisco, Tokyo, Berlin, Beijing, and interesting, the village of Swarthmore. But when you do the calculation of 190 feet above sea level, it turns out that the lawn in front of Parrish would be the new beach for sea level. So Parrish would survive. So if anybody's interested in the local lore there. And so about 60% of the population would eat. So that's the backstory. You don't hear much about that. Personally, I think that we ought to publicize that more, that would get people geared up and focused more on climate change, because the surprising thing to me is the inaction that we have with the political leaders of the world, really. So, what's keeping the Antarctic continent cold? Well, the first thing is that you have the Antarctic circumpolar current, which is shown on the left, and that's the dark blue. And it rotates around the Antarctic and forms a barrier, keeping out the warmer ocean currents. So that's the first thing that protects. Also, I'd point out that the light blue around the Antarctic continent portrayed there is the sea ice. That's the maximum extent of sea ice in 2018. There are 6 major ocean currents, and they serve to move heat around the globe and distribute it. They've been fairly stable, but now there's a period where they're migrating a bit. They're still fairly strong. The one that is, I think people have the most familiarity with, is the North Atlantic one, which is the one that is known as the Gulf Stream, and is what causes a warm climate in Europe. The cities of Europe being further north than most of the cities in the United States. I'll shift now. I wanted to just talk a little bit about the science and a little bit about why, let me go back, why the Antarctic ice sheet is stable. The other reason is that there's sort of a global downdraft over the Antarctic. It's sort of a donut-shaped air circulation pattern that dumps cold air on the Antarctic. It flows then out to the sea due to gravity and cycles back up. It's cooled. And so it acts like sort of an air conditioning system for the Antarctic. So at the moment, we're fairly well protected. But if those two mechanisms start to change, it would not be a good sign. The Antarctic is sort of the canary in the coal mine, which is why people study it, to see what's going on with climate and global warming. So shifting from the science, what I wanted to do was show the energy use and utilization of energy. I hope this is not too much of an eye chart, but on the left, I think it's a pretty good graphic. You'll have to tell me if it works for you. On the left, we have all the sources of energy, and they're listed in quads. The quads is a very large unit of energy. equivalent to roughly 36 million tons of coal. But to give you some feeling also, it is only about the amount of energy reaching the Earth from the sun every 6 seconds, which is how much energy that we get, which is why control of the solar energy is important to global climate. Okay, and on the right, we have the uses of energy. So transportation is the largest user of energy. Industrial is next. Commercial buildings and things of that ilk, and then residential is the smallest. So that gives you a pretty good feeling for the way energy is distributed, is consumed, well, both consumed and used. An interesting thing also in this graphic is that more than half of the energy is rejected as waste heat, which is one of the unfortunate things of using fossil fuels to generate energy. A lot of it is not productively used. So talking about some of the sources, biomass is one that we're familiar with, and it's historically the main way that people are used to thinking about solar energy being converted into energy for storage. And one thing to understand that all the energy that we receive in the and have benefit on the Earth is really supplied by the sun, everything except nuclear. So biomass is one of the first that was important. And one could debate whether biomass is a renewable energy source or not, because certainly it's much more renewable than petroleum, but it has the same problems. Once burned, it releases the carbon that's stored in the biomass, whether it's trees or trash or crops. So it could be considered renewable, but it also contributes a great deal to the pollution and CO2 of the Earth. Looking now at another one, which is fossil fuels, and I changed now from the picture on the right, which is energy, to another picture by Lawrence Livermore that just shows the carbon dioxide that's emitted by the fossil fuels. And you can see it's a little hard to tell what a metric ton is, but it's 4.8 million metric tons. Quite a large amount. And this is what Al Gore talks about all the time, but he sort of lost credibility for some reason, and people aren't paying attention. They should pay attention. It's a very important issue. I show this chart because I think it's pretty interesting to show who are the heavy users and polluters or providers of carbon dioxide to the air. The United States is very high in terms of carbon dioxide per person. But if you look, we don't have the same number of people, obviously, as China, which is the largest polluter, or India, which is uses much less per person, but still contributes a great deal. So the way to think about this is the height is the carbon dioxide that's emitted per person and the population scale on the bottom. So if you integrate the population times the per person, the size of the block gives you a feeling as to who are the big polluters. So the United States really needs to lead in terms of reducing our carbon dioxide emissions per person, but we also need to find a way to work with China, India, and some of the less developed countries to reduce their carbon dioxide. This is a very difficult political problem, and one that the Biden administration is working on hard. We had a period for 4 years where nobody was working on this problem, but now the new administration is working diligently to try to solve this problem. The biggest user, as I said, is transportation. And the best way to get out of all of the emissions of carbon dioxide by transportation is through electric vehicles. And again, the Biden new Inflation Reduction Act provides a lot of incentives, tax credits for EV purchase, tax credits for battery manufacture in the US, and even tax credits for selling someone purchasing a used electric vehicle. All of these are very helpful to reducing the price that people have to pay for cars. But the other thing that's happening is a market-driven perspective, starting with Tesla, obviously, and Elon Musk, who's now in his 5th generation of cars. Every car manufacturer now is in a rush to produce cars. And by my count, there's something like 107 different EV models to select from. Volkswagen just 2 days ago announced a new series of cars, and they're going to start at $300. So people that have had sticker shock are going to find some new ways of looking at buying cars. And most of the car manufacturers are looking at getting rid of their gasoline engine production by 2030 or 2035, which is a good thing. And I would predict that most everyone is really looking at their next vehicle as being electric vehicle, particularly when the prices come down and when you see the tax credits that are available. Also, maintenance is a lot less on electric vehicle, or something like 10,000, not, there's a missing zero there, versus 30,000 parts in a gasoline powered car, and no routine maintenance. And because of the efficiencies and no lost heat, the cost of running a electric vehicle is about 4 cents per mile versus 20 or 30 cents per mile for a gasoline car. Electric school buses here in Talbot County, we've just decided to purchase electric school buses as opposed to gasoline school buses. So things are moving quickly. We also need to clean up our commercial buildings. It's interesting to me that New York, the city of New York, and to some extent New York State, is mandating that all buildings must now be all electric. In other words, no fossil fuel furnaces in buildings, rather using heat pumps, the same technology that we use for air conditioning. Buying an air conditioner that pumps heat out in the summertime and pumps heat into the building in the wintertime is the way everybody is going. Improving insulation is another way to go, because if you look at it, all the heat that's we need to heat our homes is really waste heat, because it goes out through the walls and back into the atmosphere. So if our houses were 100% efficient, in other words, they didn't allow for this loss of heat, you wouldn't need any added heat. Everything would be heated by just body heat. Now you would need air conditioning in the summertime. So those are some of the things to think about in terms of cleaning up commercial. I would just mention here, if you're interested in further reading, John Doerr, the venture capitalist from Silicon Valley, has a very good book out, Speed and Scale. Very readable. And with his focus, he's talked to or gotten a lot of people that are good in looking at new technologies, which is what he's interested in, to write short articles. So there's maybe 120 different short articles in that book. It's an easy book to read. And Paul Hawkins' book, Drawdown, which Kathy Cortez, thank you, Kathy, pointed me to during our last meeting and discussion, is also still a very good book. We should be working, each one of us, to improve our homes. California now has mandated that all new residences should be all electric. And by that, they mean every new roof should have solar on it. When you look at houses with when I started out doing with my solar company 12 years ago, solar panels were not as efficient as they are today. Today, solar panels are about 20% efficient. And what that means is just about every house can cover their electric bill by putting solar panels on the roof. A smaller house has a smaller roof, but it has a smaller electric use footprint. So they balance out. The payback for solar as electricity is great. And you get quick payback, maybe 5 years or something like that is what we see with the systems that we're installing today. And with the tax breaks that are available under the new IRA, it's going to get even better than that. The third generation technology is amazing. And what really makes this work is something called net metering, where you can attach to the grid and use the grid basically as a battery. That works in states that are leading edge, like Maryland and New York and Connecticut. Some of the more backward states are not really allowing, not as good, and they don't allow net metering. So states like Indiana and Florida are not as progressive as we are. And one of the key things that we have to do is decarbonize the electric grid. Because if you think about it, if we all go to electric cars, that just transfers the pollution to the electric grid if it hasn't decarbonized as well. But it's moving very quickly, and not quickly enough, but quicker than it was 5 years ago. And electricity generation, now if you're installing electricity generation, states that are as backward as Indiana and Florida in terms of adopting new energy are both jumping on solar, because solar right now is the least expensive way to generate electricity. And so they recognize that. One would hope that each of us recognizes it, and commercial buildings recognize it. So there's a lot of public policy pushing that way, and that's something that we should all be doing. Another thing we need to do is fix food. 50% of our food by some accounts is wasted. And that food goes into landfills, it goes into garbage disposals, into sewage systems. And they're very inefficient in the way that they convert that waste food, which is stored carbon, into something that's more friendly to the atmosphere. As we fix sewage treatment plants, and that's something that we need to do in septic systems, we'll do a better job. But right now, what we really need to do is be composting our waste food or recycling it to homeless shelters and people that can accept the waste food from restaurants, the waste food from all the places where we buy food, because a lot of that is not recycled in the way that it should be. So one of the things we can do is work with our towns, cities, or our retirement homes to ask that all food be recycled. Why? Because a lot of the food is animal-based food, and animal-based food is very unfriendly to the environment, as I think most of us are aware. This is a diagram that shows how we build up carbon dioxide. This was the 1750 level. Coal, oil, gas increase that, and then land-based uses increase that to a high level. The thing that recovers that right now and convert through photosynthesis converts carbon dioxide back to oxygen are the land-based and ocean-based processes that convert CO2 back into oxygen and water. We need to move to things that are faster growing, like bamboo. Bamboo is a great solution, fast growing, and people are now I think people are very familiar using it for flooring. It should be used to replace plastic. It should be used in furniture. And more, if you look carefully, you'll see that clothing is now produced from bamboo. There are companies that are producing plant-based leather to replace animal-based leather. All of these things are market-driven and helping us reduce our carbon dioxide load. Recycling, as I mentioned, is very important, and we should be recycling as much as we can in terms of food, paper, cloth, and cardboard. It's not as easy to do as it should be, and what each of us can be doing is working with local jurisdictions to get them to collect these items and recycle them. We should also be recycling plastic because plastic, as we know, is long living and winds up in the ocean. We've got to do a better way to do this because all plastic is created from, right now, from hydrocarbons. And it's a way of storing CO2, but it's a way of polluting. We also need to be recycling batteries rather than just throwing them away. And I could get you the link, but there's a new company that's just starting up in the Northeast that is recycling batteries. And that's going to be important as we move to all electric approaches to energy, is recycling batteries, recycling the lithium and the heavy metals that are in batteries. So I ended the presentation about 5 years ago with a call of what can we do. I would just enjoin everybody to pick something and go do it. Whether you like to work with local governments, pushing them to do a better job, working with corporations to getting them to do a better job, whether you're a shareholder and want to actively promote better standards. I think back to the work that Jeb Eddy did early on with the college to get them to eliminate their investments in petroleum-based companies and move to more sustainable companies. I also think we should work with corporations that are reimagining their companies and moving to zero carbon footprints. Apple is one of the leaders in this, and we should follow that and find ways to take what they've developed and spread them across to other corporations. And then there are individual initiatives, whether it's changing the lighting and insulation in your home, stop burning organic fuels and move to electric homes. I know it's nice to have a fire in the winter, but if we can limit that use, that helps eliminate some of the CO2. And then recycling kitchen waste. Those are all important things to do. I end with the list from Drawdown. I know it's a bit of an eye chart, but if you go online, pick up the book, this chart is in there, or I can send it out to you and you can take a look. So that was what I wanted to do. And I promised DJ that I would wind up at 7:40 and we would have a time for questions. So DJ, I'm going to turn it back over to you.
Okay, thank you, Scott. And it's all right if you went a minute over. Nowhere did you mention wind power. And those of us who live in Mid-Atlantic states And even New England, there is quite a bit of controversy, and yet money is being invested in offshore windmills, if you want to call it that. And people are saying, you know, if these get installed, it's going to be able to, you know, provide power for many, many communities. So what is your opinion on wind power?
Thanks for that, DJ. Yeah, I didn't mention wind. As I say, there was a lot of stuff that got left on the cutting room floor. As you can see, wind is fairly important. It contributes about 3% of the energy, which is more than twice as much as solar. So there's been a lot of interest in wind. Wind is good where there's a, well, it's an axiom where there's a lot of wind and where there's constant wind. So you'll see wind farms on mountaintops. There's wind farms in Texas, wind farms on top of the Rockies. Those are the places that it's useful. It's not useful in a place like here on the Eastern Shore. It's not useful on flat land, too flat land. Very useful in the on the ocean because there's constant winds there. Some people don't like the look of wind, and so there's been some controversy on that. But the other thing, I'll just say I'm a solar guy, and I like solar because it just sits there and produces electricity. You never have to do anything. Windmills are rotating devices, and they need service, and they need to be oiled and maintained and things like that. If you're committed to do that, and you have a provider that has developed the wind turbine that's going to last 30 years, that's good, but there are some downsides to wind.
Right. Barbara Tinker wrote me that she is going to send something on a recorded talk on wind power. And when she sends it to me, then I can send it on to the class so they can learn more about wind power.
Great.
Okay. What do you know? And I'm asking this because of neighbors who have heat pumps. And there is a neighbor who is very much into energy conservation and all. And he has figured out a way that he can adjust his heat pump to make it more efficient, to make it run better and use less energy. What do you know about that?
I'd say go for it, and I'd love to hear what his approach is. Heat pumps and air conditioners has become more efficient because there's a new technology. It's called a scroll computer, which works in a different way than the old compressor, not computer. It works in a different way from the piston-based compressors. So the new systems are a lot more efficient than they were. And that's why I would recommend anybody that's looking at upgrading their heating system to look very strongly at heat pumps and even at geothermal, which is an even better way to heat and cool homes because it involves a more efficient means of conducting the heat by getting it from the earth as opposed to the air. But yeah, heat pumps are the way to go.
What do you know about the geothermal that they're installing or doing at the college or that they've already done?
Yeah, thanks for that. We should mention that. I don't know if everybody's aware of it, but there's a sustainability campus that's being built out on the lower grassy area down by the train station, quite extensive. They're going to put geothermal in there, which is a good plan, and then run it over to the steam plant and use that to produce energy to heat the dorm rooms in the college. I think everybody knows that we had steam heat generated by that power plant. So that's what they're doing. It's a long-term project. I wish they were moving along faster. And I think they're also going to include solar on that. Interestingly enough, the new dining hall roof has solar panels on it. So they're using solar. The college is using solar in much more constructive ways. So kudos to the college for doing that. But there's going to be, from what Michelle tells us, there's going to be a tour of that facility when we're there at the reunion.
Okay. I'm thinking about friends who are climate deniers. I don't understand. They're denying. Give me some clue as to how to communicate with these people. I don't want to get into some big argument. But what's some science that we can point to? And why are people climate deniers? You've been in this field.
Yeah, that's an excellent question. And I talk to a lot of people that are climate deniers. Some are quite detailed and have made up scientific approaches. And I don't think that the layman is prepared to talk to them in detail about climate. But what at the high level, I think you just have to talk about all the benefits of the technologies that are being used, and the fact that for instance, all the car companies are moving to electric vehicles to improve the climate, not because it's some do-good kind of thing to do, but it's because it goes to their bottom line. And why would one want to drive a car that's as polluting as the current ICE cars, gasoline engine cars are, that emit noxious odors that can kill people, provide a lot of excess heat, and emit CO2. So I think, DJ, the only good answer that I have is to be referential and talk about what other companies are doing, what states like New York that are saying that you should electrify all of your new buildings, what California is doing, saying put solar on all of your roofs. There's just a groundswell of people that are knowledgeable, that look at this, that say this is the way to go. Apple computers is going to be 100% carbon neutral, I think, in the next few years. And that's the people that I talk to, that's the best discussion to get into, because you can ask them, why would those companies be doing that if it weren't in their best interest? It's in their economic interest, but it's also in the interest of improving the global climate by reducing CO2.
Okay. Great, Scott. A great talk, Scott, but I worry about the cost. And I know that was something that went through my mind, because the cost of both wind and solar depends on local conditions. And this is done up there in Canada. Ontario has mediocre wind and solar regimes. Will locations with similar conditions be willing to pay for wind and solar? And this is another one of those political issues.
Well, what I tried to say through this conversation and discussion is we've moved through a lot of those questions, and now the case for wind and solar are very compelling. So, well, the case for nuclear is compelling too. So we should be doing all of those things, not just based on a do-good kind of thing, but because it's good for our pocketbook. If you look, as I mentioned, there are utilities that are sort of not progressive, such as Indiana and Florida, are two that I mentioned, that really are not into any terms of climate change or reducing CO2 or anything like that for do good reasons, but they've gotten there because they're installing solar, because solar is the cheapest way for them to generate electricity. So we've now gotten, we're on our second or third or probably fourth generation of this technology, and the analysis that goes with it, we can show the cost benefit, and we can do all the siting, just make all the siting decisions and tell you exactly how much energy you're going to save if you put in wind or if you put in solar. In my business, I'm asked all the time to give an estimate as to what the savings would be. And I prepare a chart and show people what the savings are. And every time I show someone this chart, they can't believe how good the savings are. They just don't realize. And I use a lot of automated software now instead of the manual ways that I used to do things. But the automated software can tell me exactly how much energy will be produced over a year for any given roof, anywhere. Well, anywhere, I was going to say anywhere in the United States, but anywhere in the world. I just click on Google Earth, look at the roof, and in a few minutes can provide an estimate of how much solar would save a person over a period of time. Now, that said, many of us are not looking to save energy over a 30-year period, but payback now is roughly 5 years. And if you put solar on your roof, it's going to increase the value of your house. So the story, DJ, across the board is renewables are good, and everybody should be looking at renewables, not for all the benefits that we talked about for the globe, which is reducing carbon dioxide, but for benefits to their own pocketbook.
Okay. Barbara Tinker has suggested a couple of great videos. I will put those in an email to everyone, but here's a question. Should we rename gas as methane?
Sorry, come again. Should we what?
Should we rename gas as methane?
I'm not sure exactly what that question is. Methane is a gas, and methane is produced by landfills. As the material in the landfills decays, methane is produced, which goes into the atmosphere. And methane is 10 times worse than carbon dioxide in terms of global warming.
Right.
As everybody knows, methane comes from cows and livestock, and that's one reason. For instance, our granddaughter, who's 17 years old, has given up beef because she doesn't believe that we should be converting plant-based carbohydrates into protein in the form of beef, and because of the methane content. I didn't have a chance to include that. I was going to. It's something that went on the cutting room floor, but modern farming techniques are now looking at having to capture the methane produced by cattle and the other waste products that are produced by livestock, to recycle them and become much more environmentally friendly. So that's another whole topic for discussion. I didn't have time to go through that in 40 minutes.
Yeah, and Barbara talks about how it is increasing in a terrifying way. And I think that I'm just conjecturing that many people do not understand that methane is worse than CO2. You know, CO2 is the bad guy. If more people understood the negatives of methane, if we called it methane, then maybe they would be more interested in trying to decrease it. All right, yeah. Now got another. Okay.
Yeah, that I agree with you, DJ, that more people would need to become aware of the methane problem. But I think there's been enough public literature and reporting about animals, and particularly beef cows that produce a lot of methane and the harm to the environment. It is about 10 times as bad as carbon dioxide. So it's a serious problem. Landfills are a great large producer of methane. And so landfills are now being capped, and the waste methane, it can either get burned, which is burned off, flamed off, which is not a good way of doing it, but converted, it can also be run into engines and converted to electricity. None of these are good ways of doing it, but much better to make sure that we don't produce methane, which is why I was saying recycle and don't put waste food and carbohydrates into landfills.
Right. Yeah, Barbara comments burning methane turns it into CO2. So, but then I have another question about, I'm going to say, the energy grid. Do we have enough energy grid for carrying the solar power or solar generated power to our homes and businesses?
Excellent question. I touched on it briefly, and what's going on, I work with the utility industry quite closely, and they're using all of these arguments to their benefit. I briefly touched it in the presentation that the energy utility companies, they spend 100% of their time working with the PUCs, public utility commissions that are creatures of the state. And the public utility commissions, because there's not much oversight of what's going on, have been very easy on the utilities and allow them to build out their grid with more capital. And so we're building, if it's not a bad analogy, a gold-plated grid, and the taxpayers and the ratepayers are paying for this. A much more rational way of doing it would be to look at the grid and convert it to support solar. Right now, the grid is by and large one way, bringing energy from a generating station to your home. As we put solar on homes, it's going to become two-way. It's pretty easy to do that, but electric companies make it appear very difficult to do, and they've convinced people to spend a lot more money than is necessary to do that. So, long answer to the question, but we should do a better job of monitoring our utility grid providers than we're doing today.
Okay. And Dave McClanahan asked, what's the timetable for electrifying rail off the grids? Not sure. Am I
Electrifying what?
have the word rail, R-A-I-L, off the grids, and I'm not sure I understand that. Dave, if you want to send me another chat to clarify that. Energy for trains, okay.
Yeah,
Right.
well, sure. Energy for trains is, we missed the boat with trains. Ted Levitt wrote a big book called Marketing Myopia that said the reason we don't have a better transportation system in the United States is that the railroads companies viewed that they were in the train business and not the transportation business, and didn't focus on better ways of doing transportation. And they could have, instead of us going with a truck-based industry over the US highways, we could have a much better bimodal approach to transportation with cargo flowing over the trains and rail system as opposed to the highways. That would have saved a lot because railroads are a lot more energy efficient than trucks or cars or any other way of transporting goods and services. But I don't see any way that the railroads, because they don't have any excess money, that they would spend money on electrification I think we've got electrification up and down the East Coast, Boston to Washington, D.C., but then they switch the engines to diesel power when they head further south. And I don't see any way that the rail system is going to get electrified. I do see that the trucking system is going to get electrified, and I think that's going to happen fairly quickly because the trucking companies can save a lot of money. Amazon is investing a great deal of money in electric trucks because it's less expensive for them to deliver that way than it is with gas powered. So I think electrification is going to occur on the highway system. I hope that's an answer to your question, Dave.
Okay, I want to squeeze in one more thing. I'm thinking of, I don't know that there is an average person, but most of the people in our country are not concerned about energy. They say they don't think about the cost. They're more concerned about convenience. And I may be off on this, but what can we do to educate the average American about these energy issues, knowing that, think about where they get their news, where they get their information. I have a real concern about lack of education on these issues.
I think that's a real problem. And as I indicated, touched on it briefly, I think one of the things we could do is improve our education system with things like that. I also think that people are going to get pulled along with what's happening in transportation, get pulled along with what's happening in the commercial area, and just the availability of the new solutions for residential, because everybody should be looking at putting in heat pumps in a house, but not many people know that it's such a good thing to do. But I think as companies become more able to describe the benefits and willing to describe the benefits, there will be more action by young people. But it's a huge problem in education, not only of young people, but people that are just growing up and starting to purchase homes, and even people starting to purchase electric cars. I was trying to work up a budget for the life cycle cost for an electric vehicle. I've had an electric vehicle for the past 5 years now, and have now 100,000 miles on that, and have some good records as to what the costs are. And it's surprising what a good deal an electric car is. So I think we need to be educating people and be getting this kind of data out to people.
Okay, so the companies also need to be educated, because if they are going to try to educate their customers, they need to be providing the kind of analysis you provide when you're selling your solar panels. I know we've approached the magic hour. Thank you, Scott. We have, yes, well, applaud, yay.
Well, thanks to everybody for participating and asking the good questions. Hope I've provided good answers. If not, send me an email and I'll be glad to respond.